Climate change is expected to increase the number and size of land on the streets, driveways, and surface parking of our communities, resulting in increased rates of runoff and increased pollution into our watercourses. To mitigate these impacts, green infrastructure redirects water away from pipes and towards more natural pathways through trees, plants, and soil.
Green stormwater infrastructure mimics natural systems, which helps to slow the rate of runoff and clean and filter stormwater. This reduces peak flows, which creates additional capacity in our stormwater system to help deal with the more frequent intense storms that we're seeing with the changing climate. Green stormwater infrastructure also helps to improve the quality of stormwater entering our stormwater system and the receiving environment in our local waterways.
Road pavement and surface parking area can cover 30% or more of land area in cities. These paved surfaces are a primary source of urban runoff and pollution. Streets and surface parking areas collect pollutants from motor vehicles, including oil drippings from engines. Nutrients from lawn over-fertilization, pet, and animal droppings also enter the drainage system. If untreated, all of these contaminants flow to receiving waters at the outfall, which could be a local stream or lake, or where the pipe goes direct to the ocean, a local beach or bay. The bacteria lead community health agencies to close beaches to avoid swimming or recreational water contact. False Creek in Vancouver has had many days where its bacteria counts were extremely high, with concerns about even dragon boat and kayak recreational use. Salmon and bird habitat is also impacted by both the water quality and quantity coming from urban drainage systems. Many municipalities around the world, including those in coastal BC, are incorporating green infrastructure into streets and parking areas at the time of development or when reconstruction is triggered. The principle of many of these techniques is to soak up rainfall, to clean it of pollutants, while providing overflow to safely convey extreme storm events. As an example, Hawthorne is a residential subdivision near Vancouver Island University in Nanaimo.
I'm Jana Zelansky, a landscape architect with Lanark. The Hawthorne subdivision drains to sensitive wetlands. We incorporated green infrastructure into the subdivision to protect downstream water quality. A key feature was this wide infiltration swale that runs between the street and the Trans-Canada Trail. Our subdivision layout couldn't accommodate another row of housing lots, so we were able to provide a relatively wide infiltration area without any loss of development yield. Driveways were designed in coupled pairs so that we could maximize the length of infiltration swale. A catch basin above each pair of driveways provides an overflow to the pipe drainage system. But overflow is really rare. The carefully designed sandy loam and compost soils quickly absorb runoff. The soils dry between storms so that we are able to maintain some lawn areas as well as plantings.
At steep slopes, the infiltration swale has gentle slopes between weirs, allowing runoff to soak in. Parts of Hawthorne also drain to this constructed detention pond, which provides amenity and habitat to the park, while providing some mitigation of stormwater flows and improving water quality before it's piped to the downstream wetlands. In a Vancouver example, green infrastructure pilot projects have included over 20 infiltration bulges at street corners. These accept runoff from street travel lanes and on-street parking. They filter the runoff into soils and provide an overflow into the existing catch basin and storm drainage system. This program encourages maintenance by interested neighbors. Similar infiltration bulges are being installed by developers in sites that drain to the Fraser River, with the green infrastructure being a key part of the attractive urban design of this neighborhood.
Since the 1970s, Burnaby has had an open watercourse policy that has preserved its natural creeks and streams. Burnaby is now using green infrastructure to improve the quality of the rainwater runoff to those creeks and streams. Rain gardens are being built in some of the densest parts of the city. Not only are they attractive features within the public realm, but they help to improve water quality and build resiliency within the city's stormwater system.
When an old arterial was upgraded in View Royal, near Victoria, the median was designed to provide an infiltration swale. Runoff enters catch basins and uses the steep slope to allow outfalls in. Step down the slope and allow infiltration into soils and the underground rock reservoir into subsoils.
Fisherman's Wharf Park is an example of how we can integrate water, plants, and people in an urban setting. The site has a large rain garden situated in the middle of it that takes water from about 2 hectares of land around it, and the land is comprised of buildings and roads. What happens is that water runs into our rain garden, and the pollutants and sediments are filtered out before that water is redirected and enters the inner harbor of Victoria.
All of the examples in this video soak in runoff from pavement and provide water quality treatment. For success, it's critical to properly design and detail these green infrastructure techniques, including site-specific sizing that considers local rainfall patterns, soil infiltration rates, drainage area, and space constraints. In some older urban areas, the stormwater enters combined sewers, where stormwater and sanitary sewage are mixed. In heavy rain events, pipe capacity is overcome, and dilute sewage and stormwater go to a combined sewer overflow. By adding green infrastructure into our street designs, we can increase the water quality treatment and reduce the volume of runoff to stormwater pipes. In combined sewer areas, the reduced volume in pipes reduces the size and frequency of combined sewer overflows. The infiltration best practices also allow rainfall to enter natural pathways through the soil to support groundwater and ecosystems. All of these benefits will increase community resilience to the more severe rainfall events expected with climate change.